My name is Ilya Benish, and I'm a building analyst for the Cold Climate Housing Research Center here in Fairbanks, Alaska, Climate Zone 8. And the cabin behind me here is on the outskirts of Fairbanks, and it changed ownership halfway through construction. The new owner contacted us at the research center and asked us if there were any energy improvements that we could suggest moving forward as he completed the cabin. So we showed up and we took a look at the place, and we saw ways to improve the energy performance in the walls, the roof, and the floor. And we've devoted several videos to those different building elements. Now, in this video, we are using energy modeling software to go back and calculate how much of a difference we've made with our improvements. And the software is called AK Warm. It's freeware, and it's provided by Alaska Housing Finance Corporation. And using that software, we've accounted for our insulation improvements, but we've also taken account the cost of energy, so that's existing cost of electricity and heating oil in this case, and the efficiency of the heating oil system. When we evaluated our exterior walls using the AK Warm energy modeling software, we started with, and you can see it here, a 2x6 wall framed 16 inches on center. And as you can see here, there's quite a bit of wood here. We actually calculated the amount of solid wood in this wall at about 25%, which means there was a lot of room for improvement due to heat losses through thermal bridging. When we added 1.5 inches of foam board here, relative to the cost of the foam board, our materials payback happened in about 10 years. As an experiment, we replaced the foam board with carefully fitted fiberglass batts. The fiberglass batts were significantly cheaper. Our payback on the energy improvements dropped down to 6 years. Now let's take a look at the roof. The roof was built with 2x10 rafters, 16 inches on center, and the rafter bays were insulated with R30 fiberglass batts. For Climate Zone 8, that's not great, but it's not horrific either. The problem we were faced with is that this roof would have lost enough heat that it would have presented a big ice dam risk, and that affects building durability. In fact, I would guarantee the first winter you had 3 feet of snow on this roof, you'd have ice dams, and that means roof damage. So in order to solve the ice dam problem, we had to put 2 inches of continuous foam board across the bottoms of the rafters, and we had to spray foam insulate where the rafters meet the tops of the walls, as that was a really vulnerable area. The payback on the materials here was over 30 years, but this is something we had to do in the interest of building durability. Now, let's take a look at the floor system. It's constructed in a very similar manner to the roof in that it uses 2x10 joists, 16 inches on center. The main issue with the floor system is that the occupant complained that it felt uncomfortably cold in wintertime. He was actually avoiding areas of the floor because they were so cold. So when we opened up the floor and got a look at the fiberglass batts and the joist bays, we found that the fiberglass was just incredibly poorly installed. We went back and we reinstalled the insulation and we added more fiberglass batts as needed. Next, we went in and we put 2 inches of continuous foam board across the underside of the floor system. That 2 inches of foam board provided a thermal break, and it air sealed the floor to a much higher degree. The end result is now a floor that's going to be comfortable to walk on in wintertime. The cost of the materials to do this work was about $1,000, and AK Warm projected a payback of about 30 years. In this case, however, my opinion is that comfort is far more important than the payback. You might be wondering, why is the payback 30 plus years out on the floor and the roof, but it's about 6 years best case scenario on the walls? And there's a couple reasons for this. The first one is that when we changed the insulation we used in the furring spaces from foam board to fiberglass, our payback went from 10 years, which is still good, down to 6 years. So part of the reason is materials. But another reason, and this is really important, that our payback is better for the walls is that the AK Warm software looks at the amount of surface area that's exposed to the exterior. And typically on a home, the walls are the greatest amount of surface area exposed to the elements. In this case, when we added up the square footage of the floor and the roof, it was almost equal to the square footage of the exterior walls. The walls, however, only had 2/3 the R value of the roof and the floor. When you average all this together with the software and look at the payback for all the elements together, we get a payback of about 10 years. Everything starts to look a lot better. I'd like to make a few more observations on working with the AK Warm software. It's really a versatile tool. It works in cases like this where we're gauging paybacks on, retrofit materials costs, but it's also a good design tool for new construction as it provides you a number in BTUs as to what it takes to heat a home for a full year. Knowing that number, you can use that information to size heating systems. The other thing that the AK Warm software does is it allows you to change the cost of your fuel. So for example, we might have heating oil at $3 a gallon right now, but if you're not an optimist, you might say, what happens when my heating oil goes to $6 a gallon? And suddenly, some of the paybacks on the materials might start looking a lot better. Keep in mind, when you're looking at insulations, you pay for them once, and then they pay dividends in energy efficiency paybacks for the life of the house. Energy modeling software does have its limitations. It's great for calculating payback, but you have to keep in mind payback is relative to the cost of materials. And currently, in the last 4 years, for example, we've seen foam board prices almost double. And that has a profound effect because then suddenly we're looking at a 30-year payback on the roof or a 30-year payback on the floor. Maybe if the floor was built differently, you'd have a faster payback. So take the numbers we've got here with a grain of salt. The other thing is, when you're looking at envelope components like this, you have to account for building durability. We want to avoid ice dams, so we have to have enough insulation that we don't have ice dams and building durability suffers. We also want to take into account occupant comfort. If you don't want to walk on your floor, that's a real problem. In the description, we will provide links to Alaska's current energy efficiency standard, and we'll provide a link to the AK Warm software. As always, we welcome your questions and comments.